Let me get my train of thought here. My train's a little derailed this morning. Here's what I came up with. Notice there's a tuning capacitor and a pot, and you would tune the radio here, and as you tune the radio, the VFO turns and the voltage would go out to this board over here instead of this pot. Now, I wanted to show you just some of the workmanship, if I can get this gear off. One of the things of this project was to work with gears. I've never really built anything with gears. I always use, like to use pulleys. Now, is this going to be a pain today? Now, if you look there, you see these 3 bolts that would hold this plate on, which would then hold the pot for the voltage for the varactors. Now, if you notice, as this comes up, there's only about a 32nd of an inch clearance. So I had to design all this just to make this a test bed to understand the tracking of the capacitor to the pot. Now, the pot has a rotation of 300 degrees, while the capacitor has a rotation of 180. So you're not going to be able to get full deflection or travel of the pot. So there might be things that go wrong there. There's a way I could actually put the frequency on here, put arrows and marks for frequency, and then arrows and marks for frequency up here, and see how close I can get them by changing the resistor value. But I have been moving along on this, and if you're watching this, my suggestion to you, if you want to build a radio, is to go to bandpass. Now, this is a front end that's the same as like a Collins R388. When you tune this knob, it tunes up at the frequency you want to receive. Now, what's different with a bandpass is it looks the same, it's just wired a little bit differently, and well, anyway, it looks the same as this. The difference with a bandpass is it only allows frequencies between 2 points, like frequencies between 3 megacycles and 4 megacycles could go through the bandpass, but above it and below it can't go through it. And that's the easiest way to do it. All your more modern Collins radios, they went to that. The R388, it tunes the incoming signal, RF amp, going into the RF amp. So you tune the antenna coil, you go into an amplifier, then 2 other passive output coils, then null out any of the unwanted frequency. Then you go to your first mixer, and on the output of that there's another set of coils, and that moves along with the IF frequency. So what they did was they created a narrow pathway for the incoming signal to go through the radio, where bandpass is a little wider, but they rely on the second, the dual conversion or triple conversion to fix that problem. Now, here is this is a remnants of a direct conversion radio, and it's got a bandpass toroids on the input of it. This is from the encyclopedia, ham radio encyclopedia, whatever it is, the big thick book. And this is a direct conversion radio. This only does code and sideband. It doesn't do AM. AM sounds squirrely. But I would suggest to you to go the way of bandpass. And I told you that, I showed you that one article in that magazine. I think it was Radiocraft. That's what you should look at. That uses band passes. So you got a band pass. Say you click it into position with a switch, and it's between 3 and 4 megacycles. So that would do your 80 meter band, and then that output of that bandpass circuit goes to your mixer, and then up from the bottom comes your oscillator, and then the output is another goes to another mixer, and then a 455. So in other words, trying to track the whole radio together. So when you turn the main knob, all your coils and everything line up for that frequency that you want to receive. Now, if you look at the Collins R388, you'll notice they use pistons and coils, and there's cams in there, and you adjust the cam. So when you turn the radio to a specific frequency, all those coils are tuned for that frequency, and they resonate and pass the frequency. And that's the way old radios were done. And at some point, someone said, you know, we can get away with just putting bandpass circuits in there. And you don't have to use the tuning caps. You switch in this circuit that's set for a certain bandpass. And there is a guy online, I think it's called Kits and Parts, and he sells bandpass boards. And you could probably use some of those, but they're passive. There's no amplifier on that board, so you got to come out. You go in with the antenna and you come out to your mixer, and hopefully you have enough signal to run the mixer. But I want to tell you, this was not any fun making. My hand coordination is not that good. This shaft, remember I showed you on the last video, this shaft was 2 thousandths over, and I have no way to turn that down, so I had to use sandpaper. And it takes a while. And then there is a little bit of adjustment on this pot. I can move it up and down. But to get these gears to mesh, and it's being a jerk now. I don't want to go down. In other words, to get that to mesh, there's a lot more involved than you would think. And I didn't run away from this. I ordered the gears. I knew the center between the two gears was like 1 1/8 inches, and I laid it all out. And one of the things that happened to me was I had it on this guy, and when this vein came up, or when these plates came up, they hit it. So I went back to using this guy, which was the original plan, but the shaft was too big for the gear. And I said, okay, and I got my calipers out, and I saw it was 2 thousandths over. I'm like, this is going to take a while. So I put on one of my box set videos. I had that playing in the background. I'm watching that as I'm sanding the shaft down. I got it all work, and then I realized that the ratio, the tuning cap is 180 degrees travel, and the pot is 300 degrees. So you're going to lose some. Now you could change the gear ratio, but that makes you have to design that. See, when you're designing something to work like something else, it's still going to have the same amount of engineering in it. And I was trying to make a modern version of a Collins radio, because they're like $500 and up. One in really bad shape you can get for $300 and $100 for shipping. So that was the radio I wanted to buy, and because it's all done really nicely. It's the Peak radio, Collins R390, and then after that they found ways around stuff, and they started cheapening and stuff. Now originally shortwave radios had 3 IF cans, and then they realized that the tubes had more gain, and people were only listening to stronger stations. They dropped back to 2 IFs. And then the front end, they took the amplifier off, like on Hellcrafter's S120, I believe it is. It has no real front end. And your SDRs, software-defined radios, they have, for each band, they got a crappy little inductor. And it ain't doing anything. That's why SDRs are so bad. I don't care if you have it made in Russia and you put extra shielding on it. The design is flawed. They're trying to do too much with that radio, and instead it's going the wrong way as far as design. It goes like metal lathe. My mother and father, after they got married, my mother bought my father a metal lathe. He was a tool maker, and it was a Dunlap, and they were left over from World War II. They were refurbished by Sears. My mother bought it for my father, and the Dunlap, I think it was an 8, no, it wasn't an AA5, AA109 maybe. Well, that lathe does everything but bad, not well. And you can cut gears and everything on it. It's got backlash gears. The centers really don't center up. It's hilarious. When you work with it, you're like, why am I having so much trouble? That's because the molds or the castings aren't straight. And I sold it when I moved here, and I sold it to a guy who was going to do the mods. There is a mods available on the internet to fix the lathe. But see, I'm a guy that when I buy something, I don't want to have to modify it. I want it to work correctly. And I have 2 SDRs that the older models, I always mention they're older, and they're poorly made, they're poorly designed. The display is amazing. That's what I bought it for. I thought I was going to lay in bed and dial through the frequencies. First thing, the antenna flops around. It's so stupid. The whole radio is stupid. And you got people on the internet, they add a special antenna to it with an amplifier. They put an external speaker on it. Before you know it, you got a DX390. Buy a DX390 used, the Radio Shack unit on eBay. But it's not going to have that. It has a digital display, but it's not going to have the waterfall. See, I kind of bought it because I thought I was going to do a certain thing with it, and it's not. Oh, and also the battery life is 2 hours. It's just, the whole thing is just poorly designed. It's a bunch of bright ideas put together. It's sort of like I built this, and I realized that the range of the capacitor is less than the pot. So you got to go with a different gear. And I could sit there and redesign this till the cows come home and get this to work just like the Collins. But how much time do I want to put into? And I need to do some housework. And the weather's been okay here. The rest of the country is not so much. My buddy from Florida called and he says it's brutal down there. It's staying up in the 90s every day. Here, we have 70-degree mornings, and then 85 by the afternoon. That's what we've been getting, 75 to 85. And there's things I should be doing, but instead, I'm thinking about this, building this, and my eye-hand coordination, the strength of my hands. My ambition is not as high as it used to be, but I did get the radio to all the work, and I really wanted to mimic the Collins radios using modern parts. But you got to look at a Collins radio, all those pistons, the cam system in there. That's why that radio is so nice. And the R390 and the Raycals, they get real big money. You're talking $1,000. They really hold their value, and the shipping's $100-something on them. But what I listen to at night is slowly going away, and I have a whole room full of radios. I told you I got a closet with like a 6 or 8 ICOM R71As. Yeah, and that radio, I didn't like it because when you turn the knob, and there is a modification, but with an old radio, when you turn in the knob, you're hearing a slight hiss sound, and then you'll hit a station. With the R71A, if you don't keep changing the capacitors every few years in the display board, it produces birds up and down on the frequencies. So you're going up and down with that radio, and you think you've got a carrier of a station. You're waiting for them to talk, and it's the display of the radio. And if you take the antenna off the radio, you still get the bird. That's telling you it's coming from the radio. Same with the SDR. You're looking at the waterfall display, and you see all these lines and stuff, and basically it's picking itself up. And they are working on it. There's people basically trying to do to the radio what they should have done in the first place. And my thing now is, I've been thinking about that. the pinnacle, I'll say it's the peak point of a tube radio, would be a Raycal or a Collins 390. That's the peak. And then Collins started making the radio smaller, and the board with all the coils on it is really tiny. And I like to watch the schematics or look at them and then see how it slowly progressed in a direction I don't want to go in. But at the same time, the stations you could pick up are disappearing. So it's just a matter of I get a bug to do something or just to see. In this case, this had many ideas in my head. Would it translate physically? Could what I designed in my head actually work in the flesh? And that's what this is. And this is still a test bed, and I can do the math. I know where the frequencies are based on this one here. Am I in the frame with this? Yeah. This capacitor over here, what angle, and then figure out the angle on this pot versus this pot and see how far I'm off. But I want to tell you, if you're going to build something, go learn the difference between a tuned front end or a passband filter. And the passband filter doesn't get tuned. It gets switched in and out. So as you go each band, you can have a wafer switch. You can also do it with diodes. And that's what I tell you. If you're at this level, like where I'm at, look into just building a radio with a bandpass filter. Or you could go with something like this. Now, let's see if I got it down here. A 3-section, 4-section would be nice. So when you tune this, you're changing the oscillator, the RF amp from the antenna in tuned circuit on this cap, and then this cap is the output of the amplifier going to the mixer, and your oscillator then goes to the mixer. But the Collins uses 3 tune sections or more, and just in the one spot there's 3 tuned circuits, and then it goes through the mixer, and it's got another set of tuned coils. It's loaded with coils, and you can see as you go through the schematics for all these different radios that at some point they're saying this is too much work to make this radio. It's too much cost, so they start cutting costs, and they put in it only what they think the customer is going to need. And the original radios, they didn't know what they were building them for. In other words, they build them as best they can build the radio, because there might be an application they don't know about, or they're being sold to the military and they want the best. And that's what Collins radios are, and Raycals. Raycals, I believe, were used on the Navy ships. The other people will correct me, but in other words, you're talking really good radios. And when you're a kid, you sit and look at them in a magazine and you drool. And the R71A, I went and bought one. And like I said, I got 6 to 8 of them. I got parts for them. I was trying to repair them for people, but they didn't want to pay me what I'm worth. In other words, if you say to the person, it's going to cost $60, $30 each way to ship it. I ain't paying that much. You're crazy. Well, that's the way that went. I set up, I repaired a couple of them, and a lot of them were bodged. Somebody went in the radio. See, the worst thing when you're a repairman is have to go in and fix what some person that was playing make-believe did. I think that's it. All right, that's it.